So every dilation has a fixed point called the center of dilation. For us, that's really going to be the origin. We're almost always going to call it 0, 0 or the origin. That's where we're going to stay to. You can produce a figure that's greater. That's called an enlargement. That's one of your vocab words. That test will be Thursday. Okay? Make sure you're getting ready for that.
Ooh.
If we reduce it, it's called a reduction. So scale factor is a fancy word that means how big or small am I going to make it. A scale factor greater than 1 is called an enlargement. Most of our scale factors are going to be like 2 or 3, and the reason being is it's very difficult for us to print graph paper that'll make a square factor or scale factor that's enormous. When we hit tomorrow, when we learn the math behind scale factoring, yeah, we can make coordinates that are as large as we need. And think about this. Let's say you're an architect and you're making a model of a house to show up a customer. You're going to use a scale factor. So you're going to do a reduction, which is less than 1, because you don't want to build a model that's bigger than the original house. They're like, no, I don't want the house, but I'll keep the model. So you build a model, a scale factor smaller. Does that make sense?
I got a question.
Yes, ma'am?
What does this have to do with rotating or rounding? Or no, rotating.
So rotations are a type of transformation.
Oh.
We haven't combined them, but I could rotate a figure and dilate it at the same time, right? Again, think about what you see on computers. It's common. Dilation is making the image larger or smaller, an enlargement or reduction, which makes it more amusing. Okay. Scale factor less than 1 we call a reduction. Most of these are in fractions like 1/2 or 1/3. It'll be pretty easy. Your enlargements are mostly going to be like 2 or 3 or 4 or something of that nature. So they're greater than. So let's look at our first problem here. We're going to find the scale factor of some images. So it says find the scale factor of the dilation. Is the dilation an enlargement or reduction? So which one of these is the pre-image? Trayson, which one is the pre-image? How do I identify it?
The one that's like the small one. The big one doesn't have the
The one that doesn't have apostrophes. So here is our pre-image, and this becomes our image, right? It's not a translation. How do I know it's not a translation?
Because it's not the same size.
Because it's not the same size. Now, it's still proportional, right?
Mm-hmm.
It's still similar. Is it congruent?
Yes.
What does congruent mean?
It means like the same.
The same.
Right?
Is this the same size?
No.
Nope.
So it's similar, but it's not congruent. Okay, so it's similar. I'm just going to put that out there for notes. Similar, but not congruent. And that's pretty much how we know something is a dilation. It is similar, the proportion is the same, but it's not the same size. So it dilated bigger. The way we find out scale factor, pick one point. I'm going to pick point A, just for the heck of it. What's the coordinates of point A? Jason, what's the coordinates for point A? Are you sure? 1, 3. So the original coordinates for point A is 1, 3. Look at point A apostrophe. Peyton, what's the coordinates for point A apostrophe?
A apostrophe?
Mm-hmm. What's the coordinates for it? The x coordinate is?
2.
Elena, you want to help her?
3. Oh.
3. And what's the y coordinate? 8.
You take forever.
Okay. Is this an enlargement?
Yes. No.
Yes, it's an enlargement. It got bigger, didn't it?
Oh, that one.
Does that make sense? Now, I could have told that just by the other, but it's easier. Let's look at number, or B. Okay, which is the pre-image?
Pre-image is the one with the
Apostrophe.
Is it the largest one or the smallest one?
smallest one.
The pre-image is the one without the apostrophe.
Oh wait,
Yeah,
that's the
I
big
agree.
one.
So it's going this way. Is it a translation?
Yes.
Are they similar?
Yes.
Are they congruent?
No.
It's not a translation. The size
No,
changes.
I'm breaking the big bar right now.
Is it, now I could do points again, I'm not going to. Is it an enlargement or a reduction?
Large. Reduction.
It's a reduction.
I
You
got it
guys,
right.
if you draw the arrows from the pre-image to the image, it'll help you from making those mistakes.
My brain is just slow today.
All right. So, some other notes I put down here. Am I going too fast?
Yes, yes, yes.
It says you dilate a figure using the origin as the center of dilation. Multiply each coordinate by the scale factor. So if you use the origin, all you have to do is multiply by a scale factor for each. So let's look at this pre-image. It says using a scale factor of 2, determine the image points. The vertices of the pre-image are A, 1, 2, B, 2, 0, and C, 3, 3. So A is 1, 2. B
Oh no.
is 2, 0. And C is 3, 3.
I got a question.
Yes, ma'am?
Why are we rewriting them if they're right there?
Because it'll help us. It'll help us make the math.
Oh.
Because we have to find the vertices of triangle A apostrophe B apostrophe C apostrophe. So it says scale factor of 2. So A apostrophe. What's 2 times 1? 2. What's 2 times 2? All I'm doing is multiplying each coordinate by the scale factor. What's 2 times 2?
2 times
4.
4.
So all I had to do here was multiply each coordinate by the scale factor.
No, I got the wrong one.
B apostrophe. What's 2 times 2?
4.
4. What's 0 times 2? 0. It remains the same. And C apostrophe. What is 3 times 2? 6. What's 3 times 2 again? 6. So now we end up with coordinates A apostrophe is 2, 4, B apostrophe is 4, 0, and C apostrophe is 6, 6. All we did was multiply each coordinate by the scale factor. What if the scale factor was like 1/2? What would change in our process?
Everything.
You would divide it by 2.
You could divide it by 2 or multiply by 1/2, either way. And that's the whole thing of it. Can you have decimals with your points?
Yes.
Can I have, go spit out your gum. Can I have a point at 1.5? Yeah, it's perfectly legal. All right.
I can't believe you didn't give me any.
The last thing I want to go to is talk about scales. Remember we said when we dilate an image, it remains similar, which means it keeps the same proportionality. It does not remain congruent. The size does change. So it says we change proportionality. The coordinates are proportional. Let's look at this one. Triangle MNO has sides of 4 centimeters, 5 centimeters, and 6 centimeters. Triangle M apostrophe N apostrophe O apostrophe has sides of 12, 15, and 18 centimeters. Or is it a dilation?
Yeah.
How would I, okay, focus. Okay,
Yeah, it's a enlargement.
how do we know?
Because the sizes are different.
If it's an enlargement, it will remain proportional, right?
Yes.
So let's write these in fractions to see if they work out proportionally. So 4 over 12, that's the one side, right? Because I'm doing the first and the first. 5 over 15, and 6 over 18. What does 4 over 12 simplify to?
This is
3 over 1.
3.
Or
4 over 12. If you don't know what it is, get your calculator and type it in. What are they both divisible by? 3. 4.
4. Yeah.
They're not both divisible by 3.
4.
So if I divide the top by 4, what do I get?
1.
Divide the bottom by 4, what do I get?
3.
So I end up with 1/3. Let's simplify 5 over 15. What are they both divisible by? 5. What's 5 divided by 5? And what's 15 divided by 5? Well, so far they're good, right? If you have a calculator, remember, if you type it in, it'll give you the simplified form. The last one is 6 over 18. What are they both divisible by? 6. 6 divided by 6 is?
How? 0?
What's 6? What is anything divided by itself?
Oh.
It's 1, right? What's 18 divided by 6?
6.
18 divided by 6. Don't blurt the answer if you don't know. 3. Are they all the same fraction?
Yes.
Then it is a dilation.
If we just look around if it was a dilation.
Or not a dilation. You've got to check things. And it works the same with the angles, right? Sides, angles, because they're going to say if it's they're going to stay the same if it's a dilation. Now this one happened to have been an enlargement, didn't it?
Yes.
Because it got bigger.
I accept that.
Any questions on dilations?